start Module 3, Cache Memory Basics. Part A, Basic Concepts in Cache. We will use 2 modules to study this topic, cache memory topic. The first one, cache memory basics, but the second one, so we will learn some, other advanced methods, formulas, things like that. All right. 8.1, memory hierarchy. First, let's try to understand this concept, memory hierarchy concept. Here, I like to draw a pyramid, several levels of memory. Here, I use 4 levels of memory. So then we can look at their relationship, try to understand the memory performance better. First, the bottom level, hard disk. Hard disk. We know hard disk is pretty big, the storage space. So right now, we put it at the bottom level. Then move 1 level higher, main memory. The storage space much smaller than hard disk, but still, pretty good for a computer doing a lot of computing work. Then another level higher, cache level. It's much smaller than the memory storage space, cache level. Finally, the top level, CPU registers. CPU registers. In our after the midterm, so we will start learning all the CPU internal structures, instruction level parallelism. After midterm. All right. So now we are doing this part. Okay. All right. First, we want to look at the relationship among these levels. First, we draw bottom up arrow, and this arrow represents one property. So that is performance. If we move from bottom up, the performance, we know the performance, data fetching performance. When you fetch data in these 4 different levels, the time used will be different. So performance, when you move from bottom up, it will be faster. Okay? Hard disk, not as fast as fetching data in main memory, not as fast as fetching data in cache, and the last one, fetching data from CPU registers the fastest. So that's simple. So that's the first arrow. Second, capacity. Capacity, if we look at the capacity from bottom up, smaller. Hard disk, the largest size, main memory smaller, cache even smaller, and CPU register very small. Here I can give you the units used for these 4 different levels. Hard disk in the category of TB, right? Desktop, laptop, several hundred gigabytes. It's very common. And some of the laptops could get TB. Main memory typically several GB, right? Several GB, 8, 16, 4. If we get a 4 GB, relatively small. Cache, several megabytes, in megabytes. several megabytes. Okay, yeah, single digit, several megabytes. So that size. Yeah. Then the last one, several bytes. Several bytes. Okay, yeah, the registers. Yeah. So you can see we use bytes for the measure. So you can see pretty small. Okay. All right. Then another factor we also want to look, the cost. Because cost is a big factor in computer system design. We have to look at the cost. For the commercial product, the cost is extremely important. Yeah. Here, along the arrow going down, the cost is reduced. Here, the cost, more precisely, the cost means per unit storage. Per unit storage. Otherwise, it's not a fair comparison, right? It's not a fair comparison. So we only look at per unit storage. Do that calculation. And the cost, when we move along the arrow going down, it is lower. It becomes lower and lower. Hard disk per unit storage cost the cheapest among all four levels, cheapest. Yeah. CPU register the most expensive. Yeah. So, all right. So with this kind of property understanding, so you can see we want to take advantage of these properties. So what is the goal? So here in our computer system design, what is the goal based on these properties? The goal is very simple. We want to get good performance. So the performance, we want to get good performance, okay, with relatively low cost. Okay, we want to combine these two factors and get a good combination so that can provide us both good performance and relatively low cost. So we don't need the lowest cost. We don't need that. Could be higher than the lowest cost. We don't need the fastest performance. It could be a little slower than the fastest performance. But we need a good combination. So not very expensive and not very slow. Yeah. Pretty fast, but not very expensive. So that's the best scenario in a commercial product. Yeah. All right, so you can see the memory hierarchy structure provides us that solution. That solution. We will see why. Yeah. Later we will see why this memory hierarchy provides us a good combination for the solution. Yeah. All right. This module, our main topic is the cache part. We know cache part connects to other parts, right? Yeah. But our main discussion is here, the cache part. Yeah. All right. So next, power of principle of locality. Yeah. Yeah. Continue from the question in the previous slide. Why we can combine, different properties to get both relatively fast performance and relatively low cost, because we take advantage of this principle of locality. We enjoy the power of the principle of locality. So let me explain in this slide why we can get that. All right. So the question, why the cache technology can greatly improve the performance? Answer is easy, right? Direct answer easy, because we take advantage of the principle of locality. Yeah. In the previous part C of Module 2, we discussed this principle of locality, the meaning. So here we do not expand that. Here we just use that directly. Okay. All right. Observation. Now we use its main property, the main property of principle of locality. So what's that? Okay. We observe this property. So in our typical, programming, CPU processing, running programs inside CPU. Yeah. And it is very common to have this property. 90% of the code is used only 10% of the time. 90%. Yeah. So look at the code, all the instructions used in one program. Some instructions are used frequently, but some of the instructions are not used frequently. So that's different. Yeah. So then we notice this phenomenon. 90% of the code is only used 10% of the time. Okay? Yeah. The opposite side, but 10% of the code frequently used, that part is used 90% of the time. So if you use the principle of locality, you can understand this phenomenon easily because of the principle of locality. Okay. So we observe this phenomenon. So now we want to take advantage of this phenomenon so we can enjoy the good result. Yeah. All right. So this kind of phenomenon, due to the principle of locality, occur at all these levels. All these levels. For example, between memory, hard disk, between cache, memory, and so on. Yeah. Yeah, because the last one, just direct fetch. Yeah. Yeah. So you can see. Yeah. So then you can see based on this phenomenon, yeah, because 90% of the code accessed, 90% of the code accessed only 10% of the time. And the 10% of the code accessed 90%. How about we move that 10% to 10% of the code in hard disk to main memory, so we can try to make the best possible performance. Yeah, 10% frequently used code we just put in main memory. Okay, so we use this principle locality once, then another time from main memory to cache. Why we just put those 10% frequently used code from main memory into cache? Then 90% of the time we just access that part of the code from cache to CPU register directly. How about that? So you can see when we take advantage of this key property, we can enjoy both parts of the factors. Performance factor, we can enjoy relatively fast performance. Yeah, because we using the memory cache as much as we can, right? So we get a good performance combination. Another, the cost side, because large part of the code we store in a relatively low cost media, right? Levels, right? Yeah, levels. Hard disk, we store, 90% of the code. Main memory, the remaining part, 90%. So relatively cheaper storage space used to store the data instructions of the program. Then, as a combination, the overall cost is not that high. So try to understand that. Okay. So in this way, at the end, we get good overall result in our computer system design. Okay. Yeah. All right. So how to apply? Yeah. So actually we already, so we summarize it. How to apply, this principle of locality, reuse commonly occurring items. Yeah, that's simple. Commonly occurred item. So the 10% commonly occurred items, so we, try to reuse as much as we can. Another 10% commonly reused item, put in cash and use as much as we can. Okay. All right. So with this kind of background in your mind, so then later, so when we understand, other concepts, so we will get a pretty good understanding. Yeah. All right, so let me finish part 8.1 here. Yeah.